Hello students, today we're going to be talking about solving equations with variables on both sides. In your book, this is in your algebra book, chapter 2, section 3. Now, the purpose of this lesson is that you should be able to solve equations with variables on both sides. This isn't too much different from what we've been doing for the past couple days. Now, one thing we do need to note is that you will run into a few equations that are called identities. Now, identity, like we've discussed before, is when one side, the left side and the right side of an equation are equal to one another. Or when, that's exactly it. So to solve for variables on both sides, you should follow these steps. 1, use a distributive property if necessary. 2, get rid of any fractions if necessary, and you might want to multiply by the LCD to help us get rid of those. 3, combine like terms on each side. 4, undo addition subtraction. 5, undo multiplication division. If you go through these 5 steps every time you solve an equation, these should be very easy. So let's practice on a few together. So 1, use a distributive property if necessary, and in this instance there is none. So we can check that off. Number 2 says get rid of any fractions if necessary. None there, so we can check that off too. Then step 3 says combine like terms on each side. Well, if I look on the left-hand side, there's nothing to combine. If I look on the right-hand side, there's also nothing to combine because the 7 does not have a variable and x obviously is a variable. So we can be done with that step 2. Now it says to undo the addition or subtraction. Now the thing we haven't really discussed is deciding what to undo first. Now, we as a group get to decide what do we want to do with the x. Do we want it to be on the left-hand side or the right-hand side of the equal sign? So imagine our equal sign is a wall, and we have the left-hand side. Oh, it's a little. Let's make that a easier size to look at. Left-hand side and right-hand side. So we need to decide first, do we want our x to be on the left-hand side or the right-hand side? So we're used to seeing it on the left-hand side, and not to mention I like to keep my x to be positive if at all possible. So what I'm going to do is I'm going to say x equals on the left-hand side. So notice I'm kind of giving us room already, and I'm saying it's going to go on the left. So that's kind of my helper to say, when I go through this from left to right, 5x should stay here on the left because it has an x. Then we're going to look at the minus 5. Well, that shouldn't stay. So to undo minus 5, we use inverse operations. So we're going to add 5 to both sides. Then we're left with 5x. Negative 5 or minus 5 plus 5 goes away. Equals we didn't touch. 7 plus 5 is 12. And then minus x we still did not touch. Then again, we're reading from left to right. 5x is okay. Equal sign we're not going to touch. 12, well 12 doesn't have an x, so it's okay there. Minus x is the issue. We are supposed to move all the x's to one side of the equal sign. So we're actually going to, because it says minus x, we're going to add x to both sides. This gives us 6x equals 12. And then to solve for our x, well, right now it says 6 times x. So, because it says 6 times x equals 12, the only way we can get rid of that is by dividing by 6 to both sides. Once we do that, we find out that our x is equal to 2, because 12 divided by 6 is 2. So now we were able to undo the addition, and then right here where the 6, we undid the multiplication and division. So let's try another one. So sometimes you'll be asked the question, is this an identity? And the way we determine if it's an identity is to figure out if the left side and the right side of the equation are equal to one another. So again, we're going to stick to the steps. So step 1 says use the distributive property if necessary. Now because we have this 3 in front of this quantity, we're going to go ahead and distribute that 3 to the entire quantity. So 3 times x is 3x, and 3 times negative 4 is negative 12. And if you'll notice, the left side and the right side are exactly the same. So we don't have to go any further. We can simply state that no solution. It is an identity. So let's try one more. So we're going to go through the steps. In example 3, is there distributive property? No. So we can move on. Are there any fractions? No. Combine like terms on each side? Well, can't combine those, and I can't combine those, so check. Then we have to undo addition or subtraction. Again, this is the part where we determine where do we want our x's to be. So let's try for the left side again. So on the left hand side, I'm going to write x equals as our marker. Then, or I'm sorry, in this case a, because that's what our variable is. Now, we read from left to right. So 5a, it has an a, so it's going to stay on the left. The minus 14 should move. So we're going to add 14 to both sides of the equal sign. That leaves us with 5a we didn't touch. Equal sign we didn't touch. Negative 5 plus 14 is positive 9 plus 8a. Then we're going to go through the line again. 5a has an a, so it's going to stay. Equals we didn't touch. 9 does not have an a, so it'll stay. And then we have 8a. So that should be moved to the opposite side. Because it's a plus 8a, the opposite of plus 8a is minus 8a to both sides. That leaves us with 5a minus 8a is negative 3a equals 9. So we've undone all the addition or subtraction, so we can check that off. Now undo multiplication or division. Now because this says negative 3a equals 9, or negative 3 times a equals 9, the opposite of multiply is divide by negative 3 to both sides. Sorry, through negative 3, not negative 3a. And this leaves us with 9a equals 9 divided by negative 3, which is negative 3. So that's our answer. Now it's your turn. What I'd like for you to do is work on this problem, and when you're done, please post your answer to Edmodo. Remember, if you're the first one to post, you will start us off. Everyone after will just reply to that post. This way we don't have one long stream of Edmodo posts. That's it for now. I'll see you next time.